Let's take Professor Richard Lindzen, for instance, who has produced paper after paper showing that climate sensitivity is around 1/4 to 1/7 of what the UN says. That means 3 watts per square metre, all anthropogenic forcings, estimated by the IPCC 0.8, 5 times as much forcing from natural causes.
The question I asked in my first video on Monckton is, why do people believe him? And here we start to get an insight. Here he is on national television in Australia, debating a professional climate scientist and easily getting the better of him. You can tell Dr. Ben McNeill is thinking, shit, I thought this would be a pushover. I wish I'd prepared. Yes, McNeill would have been wise to find out a bit more about Monckton and his arguments before coming on the programme, because Monckton certainly did his homework on McNeill.
With all respect, you are not an expert on the central question in this debate, which is climate sensitivity. How much warming will you get if you add CO2 to the atmosphere?
And he's right. McNeill isn't an expert on climate sensitivity. He's an expert on carbon dioxide absorption in oceans, which is the subject of most of his research. So when Monckton turns to an area outside of McNeill's expertise, Monckton can pretty well make any claim he likes without fear of contradiction. Let's face it, he sounds bold, confident, eloquent, and sure of his assertions. McNeill can't check whether Monckton's claims are correct, neither can the interviewer. But we can, so that's exactly what we're going to do. First, let me explain some terms that you'll hear a lot. Put simply, forcing is the amount of warming caused by whatever might be warming the Earth. It could be the sun, or a greenhouse gas, or a light reflective surface turning into a darker one. The amount of forcing or warming due to a doubling of CO2 levels is pretty much agreed on by all climatologists. Richard Lindzen, the skeptic everyone likes to quote, says this figure is about 3.5 watts per square metre, as noted in the last 3 IPCC scientific assessments. The IPCC actually puts the figure at 3.7 watts per square metre, but there's a margin of error, so we're in the same ballpark. When forcing increases, the average global surface temperature rises until it reaches a stage where the amount of energy leaving the Earth is about the same as the amount of energy being pumped in by the forcing. This is called the equilibrium temperature, and in its most basic form it's very easy to work out. Temperature equals forcing times lambda, which is the Earth's sensitivity. It's usually written as delta T to denote a change in temperature in response to delta F, a change in forcing. So forcing is like a heater in a cabin, and sensitivity tells us the final temperature the cabin will reach in response to that heat. It's important to understand the difference between forcing and sensitivity, because as we'll see in a minute, Monckton gets them completely mixed up. If no other factors are involved, climate sensitivity is about 0.27. So if we plug in a forcing of 3.7 watts per square metre caused by a doubling of CO2, we'd get an increase in temperature of about 1 degree centigrade. This is also generally agreed on by all climate scientists. Unfortunately, other factors are involved. As the Earth warms towards this level, changes happen that tend to amplify and reduce the warming, known as positive and negative feedback. Lindzen argues that more water vapour will produce more clouds, which reflect sunlight and may act as a negative feedback, outweighing all the positives. The reason this isn't generally accepted is because other climatologists have found flaws in Lindzen's hypothesis. For one thing, it only encompasses the tropics, not the whole Earth. And even clouds in the tropics not only reflect sunlight and act as a negative feedback, they also send outgoing long-wave radiation back to Earth, and so act as a positive feedback. And the other reason Lindzen's hypothesis doesn't fit is that researchers working in a completely different field, geology, found that the feedback effects from CO2 in the past were clearly positive, not negative. So these various feedbacks have to be plugged in to find out what the Earth's sensitivity really is, and therefore what the equilibrium temperature will be. Modelling is just one of many different ways sensitivity can be determined. Glaciologists and geologists determine sensitivity by looking at how global temperatures changed according to carbon dioxide level rises in the past. A review of the various results from a dozen different methods, each denoted by a different colour, shows that nearly all cluster around the 2 to 4.5 degree range. I'll squash them up so we can see them in one frame. The thicker lines show more results and greater probability. Individual results that are well outside the cluster, known as outliers, are marked with crosses. So let's just pick a result at random. This study, for instance, shows that global temperatures will rise by 10 degrees because of a doubling of CO2. And this one, for instance, says the same thing. So we now know that temperatures will rise by 10 degrees, which is 3 times higher than the IPCC estimate. What do you mean that's nonsense? Rats. The Monckton fans have spotted what I did. Yes, I completely ignored the majority of results clustered in the middle and just happened to deliberately pick the most extreme outliers. Then I pretended that they were representative of the body of evidence and claimed that we know these results are correct. You could just as easily pick a couple of studies from the opposite extreme and do the same thing. But who would do something as obviously bogus as that?
Let's take Professor Richard Lindzen, for instance, who has produced paper after paper showing that climate sensitivity is around 1/4 to 1/7.
So now we're beginning to see Monckton's performance in context. He cherry-picked extremely low figures that are clearly outside the range of most research. Then he conveys the impression that this result is correct, undisputed, known and settled. The biggest problem is that a number of papers have found flaws in the research of Lindzen, Douglas and Knox, and Monckton makes no mention of this.
And here's my own calculation, and we get 1.6 degrees Celsius as the change in temperature for a doubling of CO2. The warming we would expect to get if we doubled the CO2 concentration in the atmosphere, that is what's known as climate sensitivity, will be about 1/5 of a Celsius degree, just a little bit more than 1/5 of a Celsius degree.
In his piece in the Forum on Physics and Society newsletter, Monckton gives yet another figure for temperature rise, 0.58 degrees centigrade. Which one Monckton decides to settle on really doesn't matter, because we'll see that his calculation method is nonsense anyway. He laid it out in the APS newsletter piece. I'm not going to go over the whole thing, because people far better qualified than me have already done that. I'll just point out one of the most egregious errors that even the most scientifically illiterate can grasp. It concerns the figure for forcing, which Monckton initially puts at 3.405 watts per square metre. OK, this is lower than the accepted estimate of 3.5 to 3.7, but never mind, that's small beer compared to what he does next. He divides it by 3. So he now gives us a forcing of just 1.135 watts per square metre. Monckton says this is to take account of the observed failure of the tropical mid-troposphere to warm as projected by the models, citing a paper by Richard Lindzen. But whether the tropical mid-troposphere warms as projected or not, this isn't forcing, it's sensitivity. Nowhere in the cited paper does Lindzen cut forcing. In fact, Lindzen specifically says in the same paper that forcing is 3.5 watts per square metre for a doubling of CO2. Nowhere near Monckton's 1.135. Surely no one who testifies to Congress on the subject of climate could possibly mix up sensitivity and forcing, especially in what he claims is his peer-reviewed paper. That would be like confusing time and distance, or pressure and volume. They're two completely different things. But then our old ally comes along to show that's exactly what he did. In an attempt to hit back at his critics, Monckton justified his decision by citing a passage from Lindzen's 2007 paper. He made a mistake on the date, by the way, but it's obvious that in the passage Monckton quotes, Lindzen is talking about sensitivity, not forcing. After reading the critiques of his calculation, Monckton obviously and rather belatedly realized this. But instead of admitting his mistake, Monckton decides to simply substitute one word for another, as if no one will notice. In his rebuttal, he justifies dividing sensitivity by 3. But if we check back with his APS piece, we can see he didn't do any such thing. He divided forcing by 3, and he says so. It even came in a section titled Radiative Forcing Reconsidered. I don't think anyone could show more clearly that Monckton mistook sensitivity for forcing than this attempt at a rebuttal by Monckton himself. So as impressive as Monckton's equations may seem, and as clever as they make Monckton look in front of audiences, they're nonsense. The trouble is, audiences do get dazzled by sums and symbols and can't tell the difference between good physics and crap.
If we apply that equation to this question of whether the clouds building up would make the Earth warmer or cooler, we get an extremely clear answer. It would make it cooler if you had more clouds. I'm not going to go through this calculation now. You'll be glad to hear. Anyone who's nerdy enough to want to follow it, get my slides and read the text underneath.
Please, sir, I'm nerdy enough. First, another quick explanation. Albedo is the reflectivity of a surface. So a black surface will have a very low albedo and a warming effect because it doesn't reflect much radiation. A white or shiny surface will have a very high albedo and a cooling effect. So let's go to the slides. Monckton's hypothesis on this is called bears crap in the woods. Here we demonstrate very easily that increasing the Earth's albedo has a very large cooling effect. Well, yes, that was easy. Since increasing albedo has a cooling effect, Monckton has successfully demonstrated that increasing albedo has a cooling effect, and sitting under a shade has a shading effect. Then Monckton imagines the Earth without an atmosphere, so that an increase in cloud cover is represented by an increase in whiteness on the planet's surface. Again, no arguments about the result. If you paint dark areas of a planet white, you increase the albedo and cool it down. Monckton concludes that therefore, the higher the albedo, the cooler the planet. Well, no, that's different. A cooling effect is not the same as saying that one thing will be cooler than another. The best way to empirically show that this is crap is to apply it to a couple of planets. Venus has a very high albedo of around 0.75, while Mercury is less than 0.1. So according to Monckton, Venus should be much cooler than Mercury. In fact, it's hotter, even though it's much further from the Sun. Why? Because it has an atmosphere. Of course, Monckton eliminated the Earth's atmosphere in order to do his hypothetical calculation, but as we can see from the example of Venus and Mercury, this hypothetical exercise leads to a hypothetical result that doesn't match reality. So let's come back to the real world and put the Earth's atmosphere back. Now, instead of just reflecting solar radiation and cooling the Earth down, the clouds do what they do in the real world. They also stop radiation escaping from Earth and add warming. In his speeches, of course, Monckton doesn't tell his audience that his proof requires the omission of the atmosphere. Well then, is there anyone who can support Monckton on this?
Now, this paper was written in 2005 by a satellite nerd named Pinker. He is wholly unconcerned with the global warming debate. And what he found was this, that there was a significant, naturally occurring decline in cloud cover between 1983 and 2001. So what we know from this is that something like 4/5 of the warming over that period in the satellite era, when we can work out what caused it, was in fact caused by a change in cloud cover.
The radiative forcing, the change in temperature forced by something happening, was naturally occurring cloud cover change of 3 watts per square metre.
Hold that thought while we watch a clip from Annie Hall.
I think that my insights into Mr. McLuhan, well, have a great deal of validity.
Oh, do you?
Yeah.
Well, that's funny, because I happen to have Mr. McLuhan right here. So, yeah, just let me come over here a second.
Oh, I heard what you're saying. You know nothing of my work. You mean that my whole fallacy is wrong. How you ever got to teach a course in anything is totally amazing.
Boy, if life were only like this.
Well, sometimes life is like that. When Monckton again pontificated on the work of Dr. Pinker at a debate in Australia, his opponent Tim Lambert was ready for him.
So here we have an enormous, naturally occurring forcing, verified in Pinker's paper by 4 separate methods.
Lambert did the next best thing to dragging Pinker on stage. He had a recording of someone reading a statement from her.
The CO2 radiative forcing value that Mr. Christopher Monckton is quoting refers to the impact on the Earth's radiative balance. The numbers that we quote in our paper represent the change in surface shortwave radiation due to changes in the atmosphere, clouds, water vapor, aerosols. These 2 numbers cannot be compared at their face value. To the best of my understanding, this is the source of the misunderstanding.
This might seem amusing, but several months after hearing Dr. Pinker's words for himself, Monckton was still misrepresenting her paper, this time to members of Congress.
This is Dr. Pinker's paper establishing that the warming of that period was caused largely by a naturally occurring reduction in cloud cover, extra sunlight reaching the ground.
For some reason, they preferred to hear an explanation of Dr. Pinker's work from Monckton rather than Dr. Pinker. So once again, Pinker had to issue a rebuttal, this time to Congress, detailing Monckton's misreading and misunderstanding of her research.
I'm going to testify not, of course, as a scientist, because I'm not one, but as a policymaker. And the role of policymakers, when confronted with scientists, is to know what questions to ask. And I'm going to raise 1 or 2 questions now. It relies on a bogus statistical technique. It is defective, as I shall now show. Not very much warming is going to happen. The reality, however, is just 0.7. The IPCC should not have used that first graph. Let us now see what the true position is. The conclusion from this is that we can explain the warming by other methods.